Hey class, today we're going to add, subtract, and multiply with different polynomials. So we're going to start with addition. So before we begin, we have to remember to add a polynomial, we have to combine like terms. So let's just review like terms. So like terms are like 2x and negative 7x. Negative 8x squared, 3x squared, 13xy, negative 7xy. Anything where the variable term is exactly the same, those are like terms. And unlike terms, for example, are like 2x and negative 7y. So one's an x, one's a y. An x squared and an x are unlike. xy and xc. So those are examples of unlike terms. If the terms are alike, then you can add the coefficients. So you can add the number in front and then keep the variable part the same. And if they are unlike, then you cannot combine them. So when adding two polynomials, so I have a trinomial plus a binomial. First, you can think of this as a 1 out in front, but if you distribute a positive 1, and you can get rid of the parentheses then, x to the fourth plus 2x cubed plus 8 plus 2x to the fourth, and then plus negative 9 is still minus 9. So notice when you distribute a 1 out in front, it really doesn't change anything. So for addition, I usually skip that step and I just jump right to combining things that are alike. So an x to the fourth and a 2x to the fourth. So x to the fourth plus 2x to the fourth is 3x to the fourth. And I started with x to the fourth not because it came first, but because it was the term with the highest exponent. So I want to write my answer in standard form. So that's the term with the highest exponent. And then the next one would be the 2x cubed. There are no other like terms, so plus 2x cubed. And then the constants are like terms, so positive 8 plus negative 9 is negative 1. And that would be my answer when I add those two polynomials together. So we'll do another one. Again, since it is plus, we can skip the step of distributing and getting rid of the parentheses. So looking for the term with the highest exponent, which would be my degree, so degree of 5 here, 12x to the fifth, and negative 2x to the fifth is going to give me 10x to the fifth. The next highest exponent is x to the fourth. There is no other terms that are fourth degree, so 14x to the fourth. And then I have a negative 10x cubed and no other x cubed, so minus 10x cubed. And then I have a negative 6x and a positive 10x, and negative 6 plus 10 is positive 4x. And then I have a negative 4 and a positive 2, which would be negative 2. So that would be the answer when I add those two polynomials together. So with subtraction, what we have to remember is that, like in the first parenthesis, there's nothing out front, so it's like a 1. So you can just rewrite the first polynomial without the parentheses. But then when you have minus, it's like a negative 1. So you have to distribute the negative 1 into the parentheses. You have to subtract every term in the second polynomial, not just the first term. So negative 1 times negative 3, or positive 3x squared would be negative 3x squared. Negative 1 times 11x to the fourth would be negative 11x to the fourth. And then negative 1 times negative 7 would make that a plus 7. And then combine like terms. When you combine like terms, you're using addition. The highest exponent here is to the fourth, so I'm going to combine those two first. Negative 3x to the fourth plus negative 11x to the fourth is negative 14x to the fourth. So So combining like terms using addition. The next highest would be the squared, so positive 10x minus 3x squared would be 7x squared. And then we have an 8x. It's positive, so it'll be plus 8x. And then we have a plus 7. Combining like terms. Okay, now I'm going to multiply. Multiply, you can use the distributive property as well. So distribute 2x times x is 2x squared. Then you have to distribute the 2x times 5 is positive 10x, so you add a 10x. You've distributed the 2x to both, then distribute the negative 1 to the x, be negative 1x, and then negative 1 times 5 would be negative 5. And then combine like terms. So 2x squared, 10x minus 1x is 9x, and then negative 5. You can use the box method for something like that as well. So when I do this one down here, I'll use the box for that. Or I could use the box for this one as well. If you do a box for this one, it's 2 by 3. So you want to make a 2 by 3 box. And then you put the terms x plus 1 here. And then 2x squared, x, and negative 5. And then when you multiply corresponding spots, which is like the distributive property because you want to multiply the x by each term. So x times 2x squared is 2x cubed. X times x is x squared. X times negative 5 is negative 5x. So I multiply the x by each one. Then multiply the 1 by everything. So 1 times 2x squared is 2x squared. 1 times x is x, and 1 times negative 5 is negative 5. So the box is the same thing as the distributive property. It's just a way to organize the work instead of getting written out in one big long addition problem. It's organized into boxes. And then you combine your like terms. And so I have a 2x cubed. And then notice I have some x squareds. So 2x squared plus 1x squared is 3x squared. And then I have a negative 5x and an x. That will be negative 4x. And then I have a negative 5. So that is your answer for that one. If you use the box method, the diagonals, the like terms do line up on the diagonals like that. So that's kind of a nice way to look at it. Okay, last one. If you're going to multiply 3 binomials, oh, not the last one, but multiplying 3 binomials. So multiply the first two and then multiply that by the product by the third one. So distributing x times x is x squared, x times negative 1 is negative x. Then distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Before you multiply by the third one, combine like terms. So x squared minus 3x plus 2. And then that product times x plus 3. And then distribute again. So I'm going to do 3 by 2, negative 3 and 2, negative 3x, and then x plus 3. So x squared times x is x cubed. X squared times 3 is 3x squared. Then negative 3 times x is negative 3x squared. Negative 3 times 3 is negative 9x. So then I've multiplied the negative 3x times both, then the 2. So then 2 times x is 2x, and 2 times 3 is 6. combine like terms. So I get an x cubed right here. It doesn't have any other x cubed, so x cubed. And then these are alike. And one of them is positive and one is negative, so those actually add up to 0, so no x squared terms left. Then negative 9x plus 2x is negative 7x, and then we have a plus 6. Okay. So I'm not going to do all of these, but these ones are A is conjugates. So one is 3x minus 2 and one is 3x plus 2. If you multiply this out, you'll notice that you're going to get 9x squared, you get plus 6x, and then you get minus 6x, and then negative 4. So when you multiply conjugates, the middle equals 0, so 9x squared minus 4. It's the reverse of a perfect square or perfect square, difference of perfect squares. So if you can remember that these are conjugates and you'll end up getting a perfect square trinomial, you could jump right to that answer. B is on here because when you square something, remember that it means to multiply it by itself. A common mistake that students make is they give me the answer of 25a squared plus 4. Now, let me show you why that is not the answer. So you cannot distribute an exponent. When you multiply something by itself, you need to make sure to multiply the middle too. So 5a times plus 2 times 5a plus 2. 5a times 5a would be 25a squared. Then 5a times 2 would be 10a. 2 times 5a would be 10a, and 2 times 2 would be 4. So the two middle terms combine to make 20a. So you get 25a squared plus 20a plus 4. And so if you just distribute the square, you can see that these are not equal. It's missing the middle term. So it's something to be aware of when you square it. Now if you square both, and then 5a times 2 is 10, and then you double that, that's what goes in the middle. So that's kind of the trick there, because remember the formula for a perfect square trinomial was a squared plus 2ab plus b squared equals a plus b squared. So you can use this to go back and forth between factoring and multiplying out if you can remember it. Otherwise, just make sure when you square something, you multiply it by itself. And then again, when you cube something, like 2m minus 3 cubed means then you have to take 2m minus 3 times 2m minus 3 times 2m minus 3, which means you'll need to find this product first. So 2m times 2m is 4m squared. 2m times negative 3 is negative 6m. Negative 3 times 2 is negative 6m. And negative 3 times negative 3 is positive 9. So this is going to go back to this formula again, perfect square trinomial. You have the first term squared, then double. So 2 times 3 is 6, and then 2 of those is negative 12m, and then 3 squared is 9. And then multiply that by 2m minus 3 again to get our final answer. So 4m squared times 2m is 8m cubed. 4m squared times negative 3 is negative 12m squared. I usually like to use the box, but I ran out of room here, so I'm just going to distribute. Negative 12m times 2m is negative 24m squared. Negative 12m times negative 3 would be positive 12, 24, 36m. And then distribute the 9 times 2m would be 18m, and then 9 times negative 3 would be negative 27. And then combining like terms, I would get 8m cubed minus 36m squared plus 36 plus 18 be 44m minus 27. And that would be my final answer. So there are some formulas if you want to use them. If you cube something, there is a formula for that if you want to try to remember it, but it's, for me, really difficult to remember. There's an example here that goes along with it as well. So if it's a plus b cubed, you cube a, then it's 3 times a squared times b, then it's plus 3 times a times b squared plus b cubed. Honestly, I think it's easier just to multiply it out. But if you wanted to practice with those equations, you certainly can. So these are the shortcuts, essentially. I typically don't use those because it's really hard to memorize the formula instead of just multiplying it out. Okay, thanks for watching.